Welcome to Study Loop.
After S1 has been closed a long time, I has reached its final value of epsilon over R, the EMF divided by the resistance. So using the equation U is equal to a half Li squared, we can find the current by rearranging. So the current I is equal to the square root of 2 times the energy stored divided by the inductance L. And these values are all known. So that's the square root of 2 times 0.26 joules divided by the inductance of 0.115 henries. And hence we get a current of 2.13 amperes. Now that we have the current, we can calculate the EMF. So the EMF is equal to the current multiplied by the resistance. And this is simply 2.13 amperes times the resistance of 120 ohms. Hence we get the EMF to be 256 volts. Next, we want the time taken for the energy stored to reduce to half its initial value. So first we know that for the decay in current, I is equal to big I, which is the peak current, times e to the minus R divided by L multiplied by time t. And we also know that the energy stored in the magnetic field, U, is equal to a half L I squared. So we can substitute the expression above for the current. So that's a half times L times the peak current squared times e to the minus 2 R over L times time t, which we need to solve. And in this case, it's equal to half the peak energy stored, or half the initial energy stored in the magnetic field. And that's a half times a half L capital I, the peak current, squared. So what does that tell us? So from above we can see that e to the minus 2r divided by L times t is equal to a half. And so we can rearrange this equation by taking the natural logs of both sides to find that t is equal to minus L over 2r times the natural log of a half. And now we can substitute our values in to get the time. So this is minus 0.115 henries divided by 2 times the resistance, which is 2 times 120 ohms, multiplied by the natural log of a half. Doing the calculation, we see that this time is given as 3.32 times 10 to the minus 4 seconds, which is the time it takes for the energy to decrease to half its initial value.